morning to all. I'm N.SATHIsh, Assistant Professor in the Department of Artificial Intelligence and Machine Learning in RRB College. In this session, we're going to discuss about Q. Q is a linear data structures that serves as a container or object that are inserted and removed according to the FIFO. That means first in, first out. Whereas in stack, what we discussed already, that means stack is used in LIFO, that means last in, first out. That also linear data structures. Let me see the operations, how the queues performs. In queue, we have the four basic operations: NQ operation, DQ operations, empty, full, and peak. These are the basic operations. In stack, we have push, pop, empty, full, as well as top or peak. These three operations, which is very similar, but we seen that push and pop operation in the stack. But here in the here in the queue, we perform NQ and DQ. That means inserting or adding the element which is called as an NQ, while removing the element from the queue we call as an DQ. Initially, the stack is empty. Stack size is predefined, as well as the stack will be empty. Same manner here, queue is also the size is predefined and the queue will be empty. Here the point extends to -1. Then when you're trying to insert a data or element in a queue, then it will be incremented as a +1 so that the value 1 is inserted in the queue. That's incremented to the 0th index. Like this, for every insertion operations in the queue, that means NQ, the index is incremented. So we can retrieve the value with the help of indexes. We trying to insert the another value 2 as well as it is incremented as 1, then index is 1. When you trying to add the value 3 or inserting the value in a 3, index is incremented +1, the index is 2. When you're trying to insert another value 4, the index is incremented +1 as a 3. Here, then we trying to insert the value 5, then it's going to increment it. Suppose the queue is full. So here, when size gets full, the queue becoming full. So the insertion process take place that we call as an NQ. Similarly, when we are trying to remove the value from the queue, that we call as a DQ. In this case, what we inserted at first, that will be removed. Whereas in a stack, what we inserted last, that will be removed first. But in case of a queue, what we inserted at first, that will be removed. So the index, the 0, the value which we inserted as 1, that will be removed here. Similarly, 2 is removed. Similarly, 3 is removed in the index 2, 4 is removed index 3, and 5 is removed index 4. Then when we removed all the things, the stack will become empty. So here the stack in stack also follows the same push and pop operation. In queue also perform NQ and DQ operations. So comparing to the stack, queue is the efficient because what we inserted at first, that will be perform its operations. That means it's going to perform FIFO operations. That's why the queue is better, as well as a large amount of data can be managed efficiently in queue operations. But some of the drawbacks in also queue, that means randomly accessing the element or inserting at the middle, which leads to a complexity in this queue, as well as sometimes memory get overrated. So these are the drawbacks in the queue. So comparing to stack, queue is better. So these are the basic operations of the queue: NQ, DQ, empty, full, and peak operations. The peak means when which gets full, the value of the front of the queue, that we call as peak operations. Thank you.